So developers, let's start developing. We're gonna take on task 9 out of the 2024 Advent of Code today, and it's a kind of a weird task. Yeah, by the way, if you like this kind of a stream of consciousness solving of these tasks, don't forget to click on the buttons, avoid the bad button, but you can subscribe, you can like the video, you can comment on it, whatever you wanna do. Anyway, we have something that we are calling a disk map. And this is a weird thing because it tells us we have a file that takes 2 blocks and then we have 3 free blocks, then a file that takes 3 blocks, then 3 free blocks, and so on and so forth. So this is a kind of a run length encoding of the view of the disk. And the first file we are naming 0, the second one 1, and so on and so forth. One thing is obvious, that all the maximum length of a file will be 9. Otherwise, we can always say that this is a file of length 23 followed by 33 free spaces. So we're gonna make that assumption. And then we're gonna do some defragmenting, which is totally not the way in which you do defragmenting. Basically, you take the last non-numeric thing, non-empty thing, and you move it to the first empty space. And you continue doing that. So at the end, you're left with something like this. And then you basically need to run a checksum through this. So you multiply this by 0, this by 1, this by 2, this by 3, and so on and so forth, and this by 4, and you get some biggish number. So I really don't have any specific ideas how we can do this without actually doing it. We might get there, but let's implement this, at least the first version, as a simple simulation. So now the entry is not an array of strings, it will be an array of integers, and since our input is literally a single line of numbers, we will just do, so this is a line, and we're gonna split that line on nothing, and then just parse int the characters. Let's see the input. To be honest, I don't see any problems running with this. npm start, and we're on the 9th day, and we get those values. So now we want to actually uncompress them as if possible. So I will implement a method that has one of the best names ever, and this is an actual command in multiple languages. I will call this explode. So this will take a list of numbers and treat them as a map to the disk. So first of all, I will need to find the length of this. So we're gonna do input dot. Do I have a sum method? Yeah, I do. This is my own method, and I will use some of them. It's just a simple reduce, but it's easier to write the sum instead of doing the reduce all the time. So I will create an array of that size, of length. I'm gonna fill it with zeros, and then we have our result. The result will actually be an array of, let's define a disk cell, disk block. So that will either be an empty thing or it will be a number. So this will be an array of disk blocks. So at the very start, I will actually fill it with dots. This is a bit slower, but not too much. And we will also need a thing called file index. And initially it's 0, and we're gonna loop through our input. Size of input. Let's call this disk map. And I will have another boolean that's gonna determine whether we're processing the file or processing free space. And since the first thing is a file, we're gonna start with that. So we will say if file indicator and we're gonna need a disk index as well. Initially that's at 0. If we have a file indicator, what are the arguments of fill from start to the end? Yeah, so we're gonna do things like that. So changes all array elements from start to end to a static value and returns the modified array. So we don't need the return because we're gonna be doing that. Do we need fill? We can just do a simple for loop. Yeah, we can do fill. I get ink. Let's see if this works. Console log result and then return result, of course. But let's see if the values are correct. So we are starting. If we have a file indicator, that means we're processing a file. Then we need to use the file index. We fill using the file index. We're starting at the disk index and going all the way to the disk index plus size. And since we did a file, we're going to increase the disk file index. We're going to increase the disk index. Actually, we're going to need to do that anyway. And we're flipping the file indicator. Otherwise, we fill the same thing with dots. The file indicator is true. We can basically use both those things to say file indicator is not file indicator, but to be honest, these two lines are kind of more expressive. We're explicitly say the next thing is not going to be a file or the next thing is going to be a file. Let's see if this works. And we're going to get a disk. Explode the input and get the disk. Let's change this. We're not going to console log it here. We're just going to console log it here. Let's see if we get what we want to get. It's quite possible we don't. So we are getting, let's compare. 0, 0, dot, 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 1, 1, 1, dot, 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 2, and then some dots more. Let's see what the end holds for us. We have 777 dot 888 8 4 8s, then no dots, and then 2 9s. So this is what our disk looks like exploded. Okay, so now we're gonna need to basically run the simulation. We're gonna need to do this thing, find this 9 and put it here. So which means we need two numbers. We need the number of the last non-dot thingy. So we're gonna need last block, for example. And that's definitely not a constant. Yeah, we're gonna set it as our last block index. Let's call that, and that's gonna be disk length minus 1, since presumably we're ending on a file, but we don't have to. So while it is a dot, go back. And we're gonna need to have let first empty index, and that's gonna start with 0, and while it's not a dot, increase it. So now we're just gonna loop for a while. And yes, that's exactly what I want to do. When do we stop? We stop when these two switch. So basically the index of the first empty block, this one, is bigger than the index of the last full block, this one. So that means we cannot do anything more. So while we're doing that, we're just gonna say something along these lines. I think this is totally correct. But anyway, we're gonna say, we're gonna take the non-empty thing and move it to the first empty one. So we're taking this, the last actual block, and we're moving it to the first one, and we're clearing out the last block index. And then we're just going back, and then we're just going forward. And then we console log the disk. Let's see if we get what we need to get. We're getting something, but let's log this in a better way. I will just join it on everything, so I should get some kind of a string that looks like this. Let's see if this is a string that we have here. Yep, that's the actual value that we need to get. This is a nice check. So now we need to just calculate the checksum. So that's gonna be a simple for loop through the disk. Actually, now that I think of it, and I did make a sum method that takes a selector, so I can say sum, but how do we sum that? Well, we have the item and we have the index, and then we need to provide a value. So if the item is a dot, then the value is 0. We're skipping the dots. Otherwise, return the item times index. And that's our thingy. Now I'm very tempted to actually write this in a much terser way, so we don't have all those returns, and in this case I will allow it. So this is not a very beautiful line as it has some things, but it's relatively understandable. If it's a dot, return 0, otherwise return item times index and return the checksum. I expect this to be correct, since the sum is kind of working. It says 1928 and the value we were supposed to get is 1928. And now I have no idea how long this will take, since our initial example has 20 columns and our actual disk is a 10 kilobyte list of strings, which means we have 10,000-ish items. Let's see if this runs in a millisecond or this takes half a day. Oh, this runs in 16 milliseconds actually. Let's see if this is the correct value. Yes, it is. And to be honest, at this moment I feel that this is not the most efficient implementation, but it's 16 milliseconds. I can live with that. Let's see what happens on the second part. First time I'm seeing this. The disk definitely has a lot more continuous, much more slowly, of course, because we fragmented all the files. Whole files, yes, this makes sense, and this is what it actually does. Because now, for example, the file 9 is half here, and no, the file 9 is here, but the file 8 is half here, and so on and so forth. And the file 6 is here, and here, and here. Yeah, that makes sense. Copy moving whole files, yes, that makes sense. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. This file does not move. Oh, now we're doing proper actual optimization. So what happens now? Yeah, we're starting with the ninth. Is there a continuous space from the leftmost span? So from the left start, we need to find the first span that free space span that is 2 or more items, and we find it here. Okay, so now we have this attempt to move the 8 to a leftmost span that has 4 or more spaces. There's none, we're leaving it there as it is. So we're moving the 7 here then, the 6 cannot be moved, the 5 cannot be moved, the 4 can be moved here, the 3 cannot be moved, the 2 can actually be moved because it's just one file. So, and the 1 cannot be moved. Yeah. So now we're gonna need to do some better analysis to properly do this. Okay, let's go back to the smaller input and let's see how we do this. I have a feeling that we're still gonna need this part. We're exploding the disk, we have the disk map, we have our length, and we also have our original input, because we can use now the original input to actually find and see what is the empty line. So I will do another extraction. No, not that, but I will want to take input. Take the input and filter it. We don't actually need the item, we just need the index. And if the index is even, that's 0, 2, and so on and so forth, that's a file. Const empty if it's not a 0. It can only be odd or even, there are no other things. So we can actually find whether we can, what's the earliest that we can fix it. So we have, oh, we might not need this. So now we're just gonna go through that. This, I don't know what this does, but it doesn't do what I wanted to do. So we're looping through the files, but we want to loop through the files the other way around. So this is files.length -1, and we're gonna call this the file index. File index is bigger or equals to 0. No, it's actually bigger than 0 because we're not gonna move the zeroed file. It's at the very end. There's just nowhere to go. And we're gonna decrease this by 1. So inside our empties, we need to find the first empty. and this will actually return the value, and we don't want the value, we want the index. Find me the first empty that is bigger or equal than the file size. But this doesn't have the file sizes, the file indexes. So it will actually make sense to explode it in a different way. Let's try it. We might do that. So the files array, the files and the empties only have the indexes, the sizes. They don't have the indexes, but the index is actually of the file is the index in the files array. So index is the file name as we're using it. Yeah. So we're gonna say empties, find me an index of an empty where empty is bigger or equal to the file size, and that's the empty index. And we're always going all the way, which means, yeah, we have the empties here. So we will have an array that says 3, 3, 3, 1, 1, 1, 1, 1, 0. Great. So we have that empty, and now we have the file that should be moved. And if the index is -1, we don't move that file. Good riddance. Otherwise, that's the size of the empty. We're gonna need to move. So for this, we're gonna need to set the values of the empty. So the disk, no, we have no idea where this is. Now we're gonna do something else. So we need to set the values of those empties to the value of the index. The empty size is the initial actually index of that? No. We have no idea where the disk. We need to find where on the disk this file starts. So the empty starts. We will need to use that index of that empty. So let's go back to the example. We find out that we need to move the 99 to the first empty field, index 0. But where does the first empty start? If we go and look at here, the first empty start at 2. So on the files, we need to sum all the empties that can be, all the files that come before it. Where does the second empty start? It starts at position 8, because these are the ones before it. So we need to sum all the values of the empties and the files before that. So we have the index of the empties. We're talking about the 10th empty. Then we need to find out the 10th empty. This is gonna be suboptimal, by the way. There are some better solutions. The 10th empty has 9 files before that. No, the 10th empty has 10 files before that and 9 empties, which means that we need to do something like this. No, we're not gonna slice the files. We're gonna styles how many empties there are. So the 10th empty has 10 files before that. The empty index 1, yeah, this is confusing. The empty index 1, this one. Index 1, 2 files before that. So it's gonna be a index plus 1. We're gonna sum that, and the index 1 has 1 empty before that, and we sum that. So that's where in our code the empty is actually set. So we're gonna need to find the file start as well, and the file start, if we have the second file, it has 2 files before that. The files with index 2, it has 2 files before that and 2 empties before that, so we don't need the plus 1 over there. So now we can just say from the file start, we're just gonna move them from the empty start, the file start plus I, the index, we're gonna move that to the empty place, and we're zeroing out that thing. The one thing that is left, we don't need to actually do anything to the file array. It can stay just like this is, but we're gonna have to change the empties array because we already used it. And I think I have a bug. Otherwise, it should be just like that. Let's just console log. And I think I know what the bug is, and thanks for the example, because I think that I will mess up moving up the 2. This is kinda important. When we want to move multiple files inside the same empty. Did I save my code? Yes, I did. Let's run it. Oh, no. Well, seems like I have more than one bug, since this is totally not what we wanted to do. So I will just put in a break here. So that means we're running through this once and we're stopping. Let's see how we move the 9. 0099. Okay, that makes sense. That is what we wanted and needed. This is what we want. But what happens when we get to the 8? And what happens when we get to the 7? And how does this thing get destroyed? Well, one way to find out. Actually, there's just not that many. Let's write out the disk after each of these and see what actually happens, because we're starting good and then we're doing something, we're skipping the 8 correctly, and then we're doing something stupid for the 7. How do we, we are moving this block. Yeah, we messed up the indexes. We are moving this block instead of moving this block. So we're too off. We're 2 off on both of them. So instead of moving this here, we're moving this here. What are we missing? This has a length of 3. So most likely we're not getting this correctly, which means the file start and the empty start are wrong. I was quite sure that they were correct. So console log. Let's see that. Of size 2 to empty 0 of size 3. Moving of size 3 to empty 1 of size 3. Is that correct? Yep. We need to move this thing to empty 1 with size 3, which means that our indexes are wrong. Empty starts there, file starts there. Empty starts at 6. 0, 1, 2, 3, 4, 5, 6. No, it doesn't. Let's see, before that we have empty 1. So we're saying file slice 0, 2. Does slice not take into account the end exclusive of the element? Yep, we need to. And here are the 2 elements that we're missing. We forgot how slice works. It can happen to the best of us. Let's see what happens now. Now something else happens. 9 of size 2 to empty 0 of size 3. Empty starts at 8. Empty 0, which means we're taking slice the empty 0. Empty 0 should take 1 file. I hate off by 1 errors, and it's somewhere around 10 here. Counting files. Let's see which files do we count. No, we should count 1 file. So this means that this is correct. Empty 0. For the empty 0, what is before that is the file 2 of size 2 and the empty of none, because it's the first empty. So that makes sense. So We don't need those, we just need to do something else. So let's see, file 9. We're moving file 9, and that means there are 9 files in front of that, 0 through 8, and 9 empties in front of that, 0 through 9. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. That one has a length of 0. So yeah, 3, 3, 3, 1, 1, 1, 1, 1, 0. Let's see, 3, 3, 3, 1, 1, 1, 1, 1, 5 ones and a 0. Yeah, that is actually correct. So where do we go wrong for this? Oh, remember when I said that we don't need to take care of the files? Well, we do, because now the empty became a 1 and we're counting it as a 1, and this is both a 1 since it's an empty of 1, but there is a file before that, so we're not counting these two when we're moving the 7. Yeah, okay. This is much better and less embarrassing than actually not knowing how slice works. So we're gonna need that, but I guess we can actually have this value as an offset, because this will, since we're going to the left, it will be kind of a constant offset. So I think that if we move to an empty, something like there, we can actually increase, we can imagine that this file is now 4. Items 4 blocks long, and that's gonna be false. But as I mentioned before, we don't really care about the files array once we move past it, and it's not like we're gonna be moving the files where we actually change them, won't we? Oh, we will. Oh, we will. So yes, let's just do this, but I don't think this will solve the problem, because if I say file of the index of the empty, we can increase it by whatever we put here. Now, I do have a feeling that this will work a bit better, but it will still have some issues. Come on, we forgot the last 7. Why did we do that? We started on the correct thing, but how were we able to forget the last 7? Up to file size. 0, yeah, it looks okay. No, once more we moved this thing. So let's see the files and let's see the empties. Whether after the first move we have a correct state. No, this should be 4, not 3. Because it was 2 before and now it's increased by how much? Empty size minus file size. Oh no, it should be increased by the file size. Yeah, that's on me. So let's see what happens. We're moving the 9s, we're moving the 7s correctly. We cannot move the 6s, we're moving the 4s. And then we have this situation. We say we have a file of 4 and a gap of 0, then a file of 6, which is this one, then a gap of 0, then a file of 3, which cannot be moved. But we actually have a file of 1 that can be moved. So this means that I will actually have another array here that is a copy of the files. So for the sizing things, I will actually use the blocks. But for the file sizes, I will use the files. So we just need to see which one of these files references should actually be blocks references. Where does the file start? We are moving that file. Yeah, this should be file. Where does the empty start? For this, I think we need the blocks. The first that many blocks, sense. And where does the file start? We're gonna need the blocks as well. We're moving, that only uses the disk, and now we're changing the blocks index. So we're not changing the files, we're just changing the blocks. Let's see what happens now. And we're console logging a lot of stuff. We got something. So we got so far that we moved this thing, and then we also decided to move the 2 in this smidgen. Let's see if this is what we actually needed to get. Yep. So now counting the checksum is once more kind of trivial, and we can just copy it over from here because that part didn't change. We're still calculating the checksum in the same way. It should be just the same, 2858, 2858. So let's go back to the huge input and let's check that if this runs in any semblance of fast enough. Oh, it's about 2 seconds and it gave us some bigger number. In principle, the number should be bigger. Let's just check if I pasted it correctly. So if this is correct, yep. Let's see now if this is correct. No, it's too high. So this means that we have a special case that we're not missing. If the answer is too high, in this scenario, it would mean that something that could be moved is not moved. So we will have to take a deeper look at the actual data that we're going to do, but most likely we're going to do that in part 2 of this video. I totally hate off-by-one errors, and I totally hate index calculations, too many index calculations. So I don't think this will be too much fun for me. So far, the first part was fun. The second part, maybe not so much. Anyway, click, like, subscribe, do whatever you want with it, and keep developing.